Okay, for this video, you definitely want to make sure you have your periodic table and your calculator handy because we are finally going to start getting into some of these calculation pieces. So, first type of stoich we are going to look at is gravimetric stoich. So when we are looking at gravimetric stoich, this is basically stoichiometry where we are going to generally be using mass. Okay, sometimes we will also use moles in these calculations. But yeah, generally we're going to be talking mass-wise. So when we consider stoichiometry, the main point of stoichiometry is going to be to determine how much of something we have based off of how much of another chemical that we have. So because of that, every stoich question is going to require a mole ratio, right? If you think about how we use those ratios in the last unit, we use them when we are trying to convert moles of one thing into moles of something else. So in stoich, that's basically the entire purpose of this unit. So we are always going to need to have a ratio, right? Just like we talked about before, to get that ratio, we have to have a balanced chemical equation. So you're going to find that there's a couple of things that you pretty much need to do for every single stoichiometry question, and a lot of them are actually quite similar to what you had to do in the last unit. So steps you're going to follow. First thing you're always going to want to do is write your balanced chemical equation, making sure you include states, right? Sometimes you're going to see that a question is going to ask you like how much of the precipitate was formed. And the only way you can know which one is the precipitate is to have those states so you know which one is solid. So make sure you write your balanced equation, have all your states in there. Then you're going to write your givens. When you write them, make sure that you write them underneath the appropriate chemicals, right? Think about when we were doing some of those like pH and pOH calculations, and we were converting a concentration over to the concentration of an ion, we wrote underneath the specific chemical what we have. We still want to do that, right? And this is going to help us identify what two things need to go in our ratio because they're both going to have information written under it. Okay, then the next step we're going to follow is a step that we do with every single unit analysis calculation. And that's going to be figure out what units you're looking for, right? What does the question ask you to solve for? Has it asked you to solve for mass, at which point you're looking for grams? Has it asked you to solve for moles, at which point that's what you're trying to solve for? Okay, once you know what you're looking for, you're going to find the given that has the unit you want. Now I'm going to start with that, making sure it's on the top, just like we did in the last unit when we looked at unit analysis. And then keep going until you cancel everything out except for the unit that you want. So sometimes you guys panic a little bit when we start stoich because you think it's a whole new thing, but really it's just a whole lot more unit analysis. So as long as you kind of figured out the unit analysis in the last unit, you're actually going to find that stoich's a pretty easy unit and doesn't require too much work. If you haven't figured it out, then you're definitely going to want to spend some time figuring that out so that you kind of know where you're going with your next steps. Okay, so let's have a look at a couple of different types of examples. I'll kind of show you an example of each type. So the simplest type of gravimetric stoich just involves converting moles to moles. So in this example, it says in the combustion of propane, 2.50 moles of propane are consumed. How many moles of carbon dioxide are produced? So if you ever encounter a chemical like this one where you're like, propane, I'm not really sure what that is, you can go to your data booklet and page 4 and 5 of your data booklet have this tables, right, where it has like the name and the formula. It's all in alphabetical order, so I can scroll down to propane. Nope, hold on, it's C3H8 gas. So I now know what propane is, so we can do our C3H8 gas. Okay, it's a combustion reaction, right? It tells me it's combustion, so I should know that combustion means that I'm combining with oxygen, and that I am producing carbon dioxide as a gas, as well as water as a gas. Okay, next piece is obviously to balance this, right? Balancing is important. So I have C3, so I am going to put a 3 in front of the carbon dioxide, H8, so I'm going to put a 4 in front of the water, because 4 times 2 is 8. Oxygen-wise, right, we have 3 times 2, so I have 6 here. I have 4 more here, so I have a total of 10 oxygens. 10 divided by 2 is 5, okay? So there's our balanced chemical equation. So our given was 2.5 moles of propane. So we find the propane, which is here. And underneath it, we're going to write that 2.50 moles. Okay, our unknown is how many moles of carbon dioxide are produced. So under carbon dioxide, we can say that N equals question mark, because that's what we are trying to find, right? So when we think about what we're trying to find, we're trying to solve for moles, and specifically, we're looking for moles, oh, can't really do that if I'm already in subscript moles, of carbon dioxide. So that means the unit I want is moles of CO2. So when I look, given-wise, I have moles over here, but it's moles of C3H8, right? That's not what I want. So this is where we're going to use that ratio, right? I talked about how you're going to need a ratio in every single Stoich question that you do. If you don't have a ratio, you have done something wrong. So what's going to go on top of my ratio is going to be the 3 moles of CO2. 2 reasons why it's going to go on top. One, generally I put what I'm looking for on the top. And the second one, the unit I'm trying to solve for is moles of CO2. And we've always said that the unit that we're looking for has to be on the top. So because we balance with the 3, we're going to say 3 moles of that carbon dioxide. Okay, that's going to go over our given. The only one we have info for is that propane. So it's going to be 1 mole of that C3H8. Okay, so looking at my units, I now have moles of CO2, which I want, but now I have moles of C3H8, which I need to get rid of. But that's okay because I know how many moles I have. It was given to me over here. So we're going to times by, and it's going to have to go on top, 2.50 moles of C3H8. And just like we did in the last unit, when something didn't have a bottom part to it, we just put it over 1. Okay. Now when we have a look at our units, we should see moles of C3H8 here, as well as here. So we can cancel those out. We don't need anything else in our unit analysis because everything else has canceled. So 3 times 2.5, we wind up with 7.50 moles of CO2. Okay, so this is basically the simplest kind of Stoich because it's literally just a ratio with the other number that we have. Unfortunately, this is also the type of question that you guys tend to completely overcomplicate. You want to add all kinds of extra things in. In particular, you want to throw molar mass in. So really important to remember, we only want molar mass if we either have a mass or we're looking to solve for one. In this case, we don't have any info about mass. We're not looking for a mass. That's why we didn't use molar mass. Okay, so really important thing to make sure you're looking for so that you don't turn a simple question into something much more complicated. Okay, so here's another example. This one's a little different. So it says, if a 3-gram strip of zinc is placed in excess sulfuric acid, how many moles of hydrogen gas will be produced? So step 1, write my balanced equation. So we have zinc, right? It's an element, so just Zn solid. It's being placed into sulfuric acid, which is H2SO4, which is going to be aqueous. Okay, this is a single replacement reaction, so I am going to make a zinc sulfate, which if I check my solubility table, is going to be aqueous. And then my new element is going to be that hydrogen gas, right? So important to remember that hydrogen is one of those diatomic elements. So when we want to make it on its own, as an element, it has to be H2. Balancing wise, if we have a look at this, it is already balanced. I might just space it out a little more to make it easier to write some of those givens in. But everything balances with a 1. So givens wise, we know for zinc, we have 3 grams. Okay, because we have a mass, we are going to have to go get a molar mass. So for zinc, it's 65.41 grams per mole. Okay, so now what we're looking for is how many moles of hydrogen gas. So we're looking for the moles of this. Okay, I don't need a molar mass for hydrogen. I needed one for zinc because I had a mass, but for hydrogen, I'm only looking for moles, so I don't need a molar mass. Okay, that test or determination step is always, do I have a mass or am I looking for a mass? If I'm not, like right here, then I don't need molar mass. So we want to think about what we're trying to solve for. We are trying to solve for the moles of hydrogen. So that means obviously the units I want are moles of hydrogen. So givens wise, the only moles I have are zinc. But again, that's okay because we know we have to use that ratio. So on the top, we're going to put 1 mole of hydrogen, 1 because that's what we balanced with. And that's going to go over the zinc. Okay, I'm not using the sulfuric acid, I'm not using the zinc sulfate because I haven't written anything under them. So if I try to throw them in my ratio, I'm going to reach a point where I can't really do anything with it, and I'm kind of getting stuck. So the 2 things that go in the ratio are always going to be what you're looking for and what you have information for. So now I have my ratio. This is giving me moles of hydrogen that I'm trying to solve for. I need to get rid of moles of zinc. Well, right here I have moles of zinc in that molar mass. So we're going to times by, and we're going to flip that over. So moles of zinc, and that's going to go over that 65.41 grams. Okay, so doing that, we have now allowed ourselves to eliminate moles of zinc. Next unit we need to get rid of is this grams of zinc. Okay, so we can do that because we know how many grams of zinc we have. We have 3 grams. So we're going to do times 3.00 grams. And again, we can just put that over 1 because there is no other part to that. Okay, and now when we look at our units, we should recognize that we can cancel out grams because it's on the top and bottom as well. Now when I look, the only unit I'm left with is moles of hydrogen. Everything else is canceled. So it's just a matter of doing my unit analysis. There's a helicopter overhead. Okay, so don't forget about your significant digits. Anytime we are doing a calculation, we need to be concerned with that. So really the only given we had was that 3.00 grams, so we get to have 3 significant digits. So moles, we're getting 0.048, and then it's going to wind up being 7 because we're going to round it moles. Okay, so this question involved a little bit more than the previous example, and that's because we had a mass. So next example we are going to look at says if 1.75 moles of copper is placed into a solution of silver chloride, what mass of silver could be obtained? So balanced equation, we have copper. It is being placed into a solution. No, that doesn't work. Silver chloride isn't actually a solution. Let's just change that. Silver chloride, if you check your solubility table, is solid. So let's make it silver nitrate. That makes more sense. Okay, so this is going into silver nitrate, which is going to be AgNO3. That's a solution, so it's going to be aqueous. Okay, single replacement reaction. So we're going to make copper nitrate. So copper, because we weren't told the charge to use, we're going to check our table. The 2 ion appears first, so we're going to use that. So CuNO3, and then it's going to be a 2. Okay, check your solubility table, it's aqueous. And then this is going to combine to make that silver element, so Ag solid. Okay, balancing wise, we need a 2 here to take care of the fact that there was 2 nitrates. And then we are going to need a 2 over there. Okay, so now when we look at it, givens wise, we were told 1.75 moles of copper. And then we are being asked to determine the mass of the silver. Okay, so for copper, I was given moles. I don't need to get anything else. For the silver, I'm looking to solve for mass. So that means I am going to need to go get a molar mass, which for silver is 107.87 grams per mole. Okay, so now that we have our givens listed, our next step is going to be to do our unit analysis. So we are trying to solve for the mass of silver. So this is different than the last 2 we looked at, because the last 2 we looked at, we were looking for moles. So we started with a ratio. But this time looking for mass, right? The units of mass are grams, and I'm specifically looking for grams of silver. So in this case, I have a grams associated with silver. So I'm actually going to start with the molar mass of silver. Okay, and we're doing that because we are looking for grams, right? That's why we say your first step, always figure out what units you're looking for. So we're going to have 107.87 grams per mole of Ag. So we have our grams place that we need. We need to get rid of moles of silver. How we're going to get rid of moles of silver? Well, there's moles here with silver, but we've already used that number, so we can't use it again. But what we can use is a ratio, right? Because we're always going to use a ratio. We haven't used that yet. So to be able to get rid of moles of silver, because it's on the bottom over here, we're going to have to put it on the top. So we're going to write 2 moles of Ag on the top. On the bottom, we're going to put what we have info for. What we have info for is the copper. So it's going to be over 1 mole of Cu, right? And it's 1 mole because that's what we balanced with. So now when we look at it, we can eliminate the unit moles of Ag. So we still have grams. Next unit we need to get rid of is moles of Cu. We can do that because we know that we have 1.75 moles of copper. So we can times by 1.75 moles copper, and we can just put that over 1. And then when we have a look, our moles of copper are going to cancel. All we're left with is those grams that we started with, okay? So on your calculator, 107.87 times 2 times 1.75, right? And that's because all our numbers were on the top. Remember, we multiply by numbers on the top, we divide by numbers on the bottom. Okay, so significant digits, we had 3 in this over here. So we are going to get 378 grams of silver, okay? So this one looked different than the last one, right? Even though we had moles for one thing and grams for the other, it looks different because we were looking for different things, right? This time we were looking for mass, which is why we started with that molar mass, because it had grams. In the last question, we were looking for moles, which is why we started with a ratio, because it had the moles of hydrogen. So last example we're going to look at, we're going to go from a mass to a mass. So those are kind of the 4 different type of gravimetric Stoich questions. Moles to moles, moles to mass to moles, and mass to mass, okay? So our question says iron 3 oxide is synthesized from its elements. So that means we are doing a formation reaction. So we are doing iron plus oxygen. Okay, so one of the really important factors in Stoich that sometimes you guys forget about is just writing the correct balanced equation. Sometimes I see some of you, you practice the Stoich so hard and you can nail the Stoich, but you don't write the right balanced equation. And if you don't write the right balanced equation, it has a couple of impacts. Okay, first impact, you might use the wrong ratio. The second impact is if you don't know that like oxygen is O2 and you just use it as O, that's going to impact like molar masses, it's going to impact ratios, it's going to kind of have that like trickle down effect. So really important to make sure that you can write that proper balanced chemical equation, because it's kind of that gatekeeper to actually being able to do Stoich. All right, so product-wise, iron 3 oxide, so we're going to make Fe2O3. Okay, that's a solid. All right, so we need to balance this. So 2 in front of this, 3 in front of this, and I guess a 4 over here, right? Whenever you have big numbers, which we kind of do here, always double check that you can't reduce. But because we have a 4, a 3, and a 2, we can't possibly reduce that any. So givens wise, what are we told? We're told if 2.5 grams of that iron oxide. So we have a mass for Fe2O3. That means we need to go get a molar mass. So 2 times 55.85 plus 3 times 16. So an important thing to notice, the coefficient we balance with does not alter your molar mass, okay? I'm only interested in the symbols themselves, okay? So that's why I'm just doing 2 irons and 3 oxygens when I'm getting that molar mass. Okay, and I get 159.70. And that's going to be grams per mole, okay? All right, so what are we looking for? We are looking for the mass of oxygen. So this is our unknown. Okay, we need a molar mass for that. So each O is 16. 16 times 2 is 32. So 32 grams, and that is going to be per mole. Okay, so Now when we do our calculation, our next step is think about what we're looking for. We're looking to solve for the mass of oxygen. So that means I need grams of O2. So I look at all my givens. Every single one of them has grams. The only right one to start with, though, is the 32 grams per mole. And that's because this is the only grams written with oxygen. The grams over here are iron oxide, so they're not really what we're looking for. These are the grams we want to start with. So we're going to start our unit analysis with 32.00 grams, and that is going to be per mole of that oxygen. Okay, so now what we need to get rid of? We need to get rid of moles of O2, right? Because all we want is grams. So the only moles I've written right now of oxygen is this, but I've already used that, so I can't use that again. So that's where we're going to use our ratio, right? Remember we talked about how every question is going to have a ratio in it. So 3 moles of oxygen goes on top so that I can cancel out, oh, what did I press there? I have no clue. Sorry. So 3 moles of oxygen on top because we have 3 in our balanced equation, and that is going to go over our 2 moles of Fe2O3. All right, so now we can eliminate moles of oxygen. They're gone. Next thing to eliminate is going to be moles of Fe2O3. Well, right here we have moles of Fe2O3, so we're going to take that molar mass and we're going to flip it. So we're going to do times moles of Fe2O3, and then we are going to divide it by the 159.70 grams. Okay, so again, look at those units. We can get rid of moles of Fe2O3. Okay, last thing to get rid of is this grams that's associated with Fe2O3. And we have this 2.50 grams that we haven't used yet, which is grams of Fe2O3. So we're going to times by the 2.50 grams. We'll put that over 1. Now when we look at our units, we should be able to cancel out those grams, right? So everything canceled. The only unit we're left with is the grams that was associated with the oxygen, which is what we were trying to find. So we're going to do 32 times 3 divided by 2 divided by that 159.7 times 2.5. So significant digits. We were only given this number as a given, the 2.50, so it had 3 sig digs, so it's going to equal 0.751 grams. Okay, so those are kind of the 4 different types of gravimetric stoich. There's moles to moles, mass to moles, moles to mass, and mass to mass. Okay, it's important to make sure that you practice all 4 types. Sometimes you guys just tend to really focus on the last type because you're like, oh, that's the hardest, and if I can do the hardest, I can do everything else. And then what happens is you get those simple questions and you start throwing molar mass in when you don't need it, and then you're like, this, either you recognize that it doesn't work, but you're not sure why it doesn't work, or you don't bother looking at your units, and then you come up with a number, but what you've solved isn't actually the right thing, right? And that's why we call this unit analysis, because we look at our units as we go and we cancel them out. Okay, the more you practice, the easier unit analysis becomes. Eventually, usually you find you reach a point where you're like, I don't really even need to think about it, I just kind of do it. Okay, so that is your gravimetric stoich.